guys. Okay, so today we're going to talk about chapter 12. Chapter 12 is super short, which is good. And the homework for chapter 12, there's only like 4 questions on that part. And so just make sure you really get it, but it's not a huge chapter, so it's not a big deal. Okay, so we talked about crystalline solids in chapter 11, and just remember that they're very structured and orderly. They generally make these geometric shapes. That's all you really need to know about those. And they do form a lattice, and that's just the arrangement of the particles in the crystalline solid are called a crystal lattice. So here's kind of a breakdown of all the types of solids we're going to talk about, and don't worry, each of these have their own slide that we'll go through and talk about. So the main ones we have are molecular, ionic, and atomic solids. So molecular solids, those are those covalent molecules. So just remember those are nonmetals only. Okay, and these are going to have IMFs. And that's how we'll rank them. Okay, ionic solids are, of course, ionic. Just remember that that's a metal and a nonmetal. And the big thing with that is when ionic solids break apart, they break into ions. Okay, and atomic solids, those are just composed of atoms. So there could be more than one of that element, but it's just one element, like one type of element. So we have non-bonding. These are normally noble gases. We have metallic, which of course are metals. And then we have network covalent. And these are either they have carbon or silicon with oxygen. Okay, so it's either carbon alone, which is like what a diamond is, or we've got silicon and it's with oxygen normally. Silicon's not normally by itself. Okay, so here's some examples of molecular solids. Just remember these are generic covalent molecules like carbon dioxide and water and glucose. Okay, don't forget about your intermolecular forces like dispersion or LDFs, dipole-dipole, and hydrogen bonding. Okay, and one thing to note from this one is that these in general have very low melting points. Okay, they have weak attractive forces. They're generally less than 300 degrees Celsius, but most of them are going to be gas or liquid at room temperature, just depending on their intermolecular force. So they're not going to be solid at room temperature. Some of them are bigger ones, but most are not. Okay, ionic compounds or solids. Just remember, these are held by attractions between those oppositely charged particles, the ions. Okay, so the positive cation is attracted to the negative anion, and they come together, and then they've got that attraction. And then we get to our atomic solids. So remember, metallic ones are held together by metallic bonds. And they do have varying melting points. It just depends on what type of metal it is, what the melting point is. Oh, let's go back to ionic solids. Sorry, y'all. These have very high melting points. So just make sure to jot that down. Okay, we've got those non-bonding. Remember, I told you before, these are those noble gases. And remember, those are always gas at room temperature. So they have super, super low melting points. Okay, they have very weak forces, and they're only going to have those LDFs. And so they have very low melting points. Okay, network covalent. These have the highest melting points, and they're generally over 1,000. Actually, most of the time, they're about 3,000 Celsius, which is super high. Okay, so here, we're going to classify if they're molecular, atomic, or ionic. So remember, molecular, we're looking for those covalent compounds. So B, this one, it's going to be molecular because it's covalent. Okay, it's got only nonmetals present. Remember, ionics have a metal and a nonmetal, so that's what C is. And then A is only an element, and so this is an atomic solid. Okay, and then it's going to specifically ask what type of atomic solid it is. So remember, we have the non-bonding, which is noble gases. We have metallic, which is a metal. And we have network covalent, which is only carbons and silicons. So this is going to be our atomic metallic solid, because gold is a metal. Okay, so this is just going through the different types of network covalence. Remember, I told you carbon is one of the main ones. So graphite is network covalent, and of course pencils use graphite now. And the thing with graphite is that they have this trigonal planar geometry. I don't know if y'all remember that from chapter 5, but trigonal planar. And they come off in sheets specifically. Okay, so here you can see in the diagram, they're in sheets. There's this layer of graphite here. And remember the dotted lines, those mean IMFs. And that's how they're being held together with covalent bonding. Okay, also they have a slippery feel. They're also used for lubricating and things like that. They're also insulators. Okay, and then we have diamonds, which is also just carbon. Okay, but this one has a different geometry. It's got that tetrahedral geometry, which is really more structured because it's got 4 paths where it bonds instead of 3. Okay, and because of that, diamonds are much more rigid. They're much harder. They do have the same melting point because it's only carbon, but they're still insulators. Okay, and then there's a carbon molecule called a buckyball. It's just 60 carbons, but it kind of looks like a soccer ball, the way they're arranged. Okay, again, they're going to have the same melting point. Okay, this is also how nanotubes are made. They've got graphene nanotubes. There's just different kinds of nanotube technology that we're using right now. And of course our silicone, just all the silicates. This is what I was talking about, the Si with the oxygen. This is a network covalent. Also quartz. Okay, notice they don't have as high of melting points. They're still over 1,000. 1,600 Celsius is still a really, really large number. But, you know, silicates, we're talking like glass. That's that amorphous form though. Quartz, we're talking like maybe on your watch, you may have a quartz watch face. So they're going to be more sturdy than like a glass watch face would be. And that's it. So hope y'all enjoy chapter 12. Bye.